Click the bell icon to get latest videos from Ekeeda.
Hello friends, in previous lecture we have discussed about the techniques of collision resolution, separate chaining and linear probing. Now we have discussed about the quadratic probing. In quadratic probing, the gap between the probes is added of the previous one. That is, the successive output is added so that the probing gap is different compared to your linear probing. Let us look at the quadratic probing. Quadratic probing is a probe sequence in which interval between the probes is increased by adding the successive outputs. Now these outputs are taken from the quadratic polynomial. So we define a quadratic polynomial to get the increased value of the successive output. We have quadratic polynomial to the starting value given by the original hash computation. We find out the hash computation, we take out the successive output and we add the values to the starting value. So our value gap, or I can say the values differentiation, is always depending upon the quadratic polynomial output. So we have the quadratic probing, hence the name quadratic probing. Now we look at the program to write down this quadratic probing function. That is, we are going to have the value stored using quadratic probing technique. Let us begin with the topic. I have defined a class named as quadratic probing hash table with the values as current size and max size. And I have defined two arrays, keys and values of the type string. Once this is done, we call the constructor, in which we are going to have the parameter called as capacity. This value of capacity is taken from the user. We have current size value as 0 since it's a starting point. Then we take the value of max size from the user through the variable capacity. That is, we transfer the capacity value to the max size. We write down max size equal to capacity. Then we need to define the size of the keys and values array. We write down keys equal to new string max size and vals equal to new string max size. So we have keys and value as same as the max size. Once this is done, then we will write down the function to clear the hash table. We write down make empty, that is to make the clear hash table. We write down current size equal to 0, keys equal to new string max size, and val in similar pattern we write vals equal to new string max size. This is to clear the hash table. Now we will try to get the size of the hash table. We have public int get size. So we need to get the size of the hash table. We have already discussed in the previous lecture, we store the size of the hash table in the variable called as current size. So in this function get size, we are going to return the variable value called as current size. We have public int get size function in which we are going to return the value as current size. Now we will discuss how to make sure that the hash table is full or not. That is to check whether the hash table is full. If it is full, we cannot insert the value into the hash table, and if it is empty, we cannot delete the value from the hash table. Hence we need to have a check on whether to insert the value or delete a value depending upon whether the function called, that is whether the hash table is full or not. Let us discuss one by one. I have defined a function called as is full. Now the hash table is going to be full when your current size equal to max size, that is the capacity is full. So in case of this, we have the function called as is full, which is going to return the value as current size equal to max size. In similar pattern, we are going to check whether the hash table is empty or not. We define a function called as is empty. In that, we are going to get the size. That is, basically we are going to return the variable value called as current size. If it comes out to be 0, it means that there are no key value pair present in the given hash table. So we return the value as current size. Function is called whose value will now become 0. This is how you check whether the hash table is full or not. Now we will write down the function to check whether the hash table has the key and also try to get the value. Let us begin. I have defined a function called as contain, in which I am going to take the value from the user through the variable called as key. Once this is taken, I will check whether the key is present or not. We write down return get key not equal to none. Since this is not equal to none, it means there is some key present in the given. That value of the key is written. That is, your particular key will be written. So we write down return get key not equal to none if the hash table contains a key. In similar pattern, we check for the hash code. We have int hash string key. We return value key dot hash code function is called up with the parameter as return key dot hash code function is called, in which we are going to divide it by the maximum size, but we are not going to take the quotient, we are going to take the remainder. Hence we write down return key dot hash code function mod max size. This is how you take the value of the hash code of the given hash table. Now we will look at the function to insert the key value pair in a given hash table using the concept of quadratic probing. You must remember, in case of quadratic probing, we have the quadratic polynomial whose output is added to the starting value. So the gap between the probes is depending upon the what output you get from the quadratic polynomial. Let us look at the function to insert the key value pair in a given hash table. I have defined a function called as insert with the parameter key and value of the return type string. First, I will transfer the key. We write down int temp equal to hash function is called with the parameter key. So this value are transferred to the temp. Then we are going to write down the values. First, I transfer this temp to I. We write down int I equal to temp and h equal to 1. This is to calculate the quadratic polynomial. Then we go for the do while loop. You must remember, in case of do while loop, even though if the condition is false, at least once the do while loop executes. Let us look at the do while loop. Do, inside that we are going to check for the condition. If key is I is equal to null, so it means there is a gap. So we can fill up this gap. Let us check with the condition. We have if key is I is equal to null, so we can insert the value. First, the key is taken and its corresponding keys I is transferred. So we write down key is I equal to key. Once key is transferred, its corresponding value needs to be transferred. In similar pattern, we write down vals I array equal to val. So val is transferred to the vals array with the index location I. Once this is done, it means we have inserted the value and its key correspondingly successfully. So your size is going to increase. We write down current size plus plus, and this all set of values are written. Now we will check for the while condition, but before that we need to check with the another set of values key. Let us check with the another set of if condition. If key is I dot equals key, so we have the value taken from the user key and that is equals to the key i's. In that case, we have found out the key, its corresponding value needs to be transferred in this case. So we write down vals I equal to val. Since we have found out the key, its corresponding value only needs to be written up. So we write down vals I equal to val. This is taken from the corresponding key which we have found out in the keys I dot equals key. This value is written. Now we will look at the quadratic polynomial to get the quadratic probing. You must remember, we are going to deal with the quadratic polynomial. Let's look at how to write down the quadratic polynomial. I have written I equal to I plus h multiplied by h plus plus. We have taken h value as 1. So we have I plus 1 multiplied by 1, that is your h, and then it is incremented. This value is divided with the max size, but we are not going to take the quotient, we are going to take the remainder. So we write down I equal to I plus h multiplied by h plus plus. This is your quadratic polynomial kind of a thing. Mod max size. So whatever remainder comes is going to be different for every probing. This is going to be doing while I is not equal to 10. By the time while I is not equal to 10, we are going to have this successive probing. Hence the name successive quadratic probing, because we are going to go for the value very differently. You must remember the value of I. I is what? I equal to I plus h multiplied by h plus plus divided by max size, but we are not going to take the quotient, we are going to take the remainder. Hence we are going to use the modulus remainder sign while I is not equal to 10. While this condition is true, we are going to insert the key value pair in the given hash table. Now we will move to the another set of functions. Now we will discuss how to get the value for a corresponding key. Let us look at the function. I have defined a function called as get, in which I am going to pass the parameter called as string key. Once I get, I need to have the value of I. I called the function called as hash with the corresponding key, and I am going to have the h variable value as 1. Now we will check with the set of condition. While key is I not equal to null, it means that there is some value present in the given hash table that the key is to be found out. Now we will check with the particular key. We have if key is I dot equals key. So once the key is taken from the user, we need to check whether it is present in the given hash table. We write down if key is I equals key. In that case, corresponding value needs to be fetched up. We have return vals I. Once this is done, then we have to increment the value of I. That is, we need to add the successive value of I. How do we add the value of I? Yes, you have guessed it right. It is going to be I equal to I plus h multiplied by h plus plus. This is called as post increment. Mod max size. Once this is done, then I value is fetched up. So we have system.out.println I value displayed. Once this is done, the corresponding key and its corresponding value is fetched to the user. So once this is done, we are going to return none. This is how you fetch the corresponding key from the user and its corresponding value is displayed to the user. Now we will discuss how to remove a key and its corresponding value from a given hash table. I have written a function called as remove with the parameter key. Then I will check whether the key is present or not. For this, I need to call the function as contains. We have the condition if contains key not. So we have not of contains key. If this is done, then we return the value. We write down if not of contains key, then return the value. If not, then we find out the particular key and its particular value is deleted. It is very important to find out the keys in a given hash table. Let us look at the condition. We have int I equal to hash key and h equal to 1. Then while key dot equals keys I is not, that means this is not found out. We write down while key dot equals keys I not. While not of key dot equals keys I, we have the value of I. We write down I equal to I plus h multiplied by h plus plus mod max size. When this is done, then we have to make sure the keys and values point to null. We write down keys I equal to vals I equal to null. So the keys and its corresponding value both point to the null storage. Now we look at the function to rehash all the keys. For I equal to I plus h multiplied by h plus plus. This is called as post increment. We have I equal to I plus h multiplied by post increment of h plus plus mod max size. Once this is done, then we check with the keys. Keys I not equal to null. While this is true, we have I equal to I plus h multiplied by h plus plus mod max size. This is how you increment, so that we have to rehash all the keys. Now we will look at the logic to rehash. I take a variable called as temp1 in which I am going to store keys and its corresponding location. That is keys I value array. It transferred to the temp1. And in similar pattern, vals I is transferred to temp2. Now we will make sure that the keys and values point to null. We write down keys I equal to vals I equal to null. Since we have deleted with this one, we need to decrease the size. So we write down current size minus minus. Once this is done, then we need to call the insert function so that we can insert the key and corresponding value. Now this insert function will be called with new set of values, that is your temp1 and temp2. Once this is done, then again you need to decrement the size. We write down insert temp1 comma temp2, and then once we have done with the rehashing, we have current size minus minus. This is how you rehash all the keys in a given hash table. Now we will look at how to print the hash table using the quadratic probing technique. The hash table consists of key value pair. Let us look at the function. I have defined a function called as print hash table of the return type void. I will start with I equal to 0 and go up till max size. This max size is defined by the user using the variable called as capacity. Through the constructor we have passed the value of capacity to the max size. So we write down for int I equal to 0, I less than max size. Then we will check with the keys. In case of hash table, all the values are stored in the keys. If you are going to find out the key, then its corresponding value you can find out. If you are not able to get the key, its corresponding value won't be available to you. So we have the condition if keys I not equal to null. So in case keys values comes out to be true, that is your null value. It means key is not present there. It is null. So you are not able to get the value. In case of hash table, we always have the key value pair. So we need to find out the key, that it is not equal to null. And then only we are going to display the corresponding value. We write down the condition if keys I not equal to null, then only we are going to fetch the value. We have system.out.println keys I. So corresponding I location keys will be displayed, and in similar pattern its value will be displayed using the index of I. We have keys I, its corresponding value I is displayed. Like this we are going to display the hash table. Now we will look at the class in which we are going to give a user a menu driven approach so that he can perform the list of operation on the given technique using quadratic probing. Let us look at the class. I have defined a class called as quadratic probing hash table test. Let us go inside the main function of this class. We have scan. Scan is the object of the scanner class. This is taken so that we can take the input from the user. We have scanner, scan equal to new scanner system.in. So the value is taken from the user through the object of the scan. Then we write down system.out.println hash table test. Once this is done, then we will ask the user to enter the size. You must remember we need to have the value of size from the user so that we are defined with the size of the hash table. We write down system.out.println enter size. This information is provided to the user. Now we will make the object of the class. We write down quadratic probing hash table. We have taken the object called as QPHT. We write down quadratic probing hash table. QPHT is the object. How do you understand it is object? By checking with its keyword new. Now this value is taken from the user. We write down scan.nextInt. Scan is the object of this scanner class. So that we take the value from the user. Scan.nextInt, and this value is passed to the object of the class. We have QPHT, which value is taken from the user and passed on to the QPHT. Once this is done, then I defined a variable called as ch of the char type. This variable is taken to check whether the user wants to continue with the set of operations or not. Its value is taken from the user. Let us say if user enters y, it means yes, the user wants to continue with this set of operation. Let us take the another set of condition. User enters n. It means user is not interested in going further with this set of operation. For this, we have the variable called as ch of the type char. Once this object of the class is created, then we need to give the user a menu driven approach. A menu driven approach gives the user the flexibility to choose the options of the operations he can perform. For this, I am going to use the do while loop. Let us look at the conditions which the user can perform. We have do hash table operation. Number 1 is for insertion. Number 2 is for remove. Number 3 is to get the value. Number 4 is for clear. And number 5 is for size. This set of operations the user can perform. His choice is taken from the user. We write down int choice variable. This value is taken from the user. User needs to have the value from this set of operations. This value is stored in the variable called as choice. We have int choice equal to scan.nextInt. So out of this set of value, user chooses one set value and this choice is taken into the variable called as choice. Once choice is taken from the user, we need to perform the given set of operation. For this, I am going to use the switch concept. We have switch choice case number 1. enter key and value. This key and value is taken from the user. So we call the object, we have the object of class called as quadratic probing hash table, which is QPHT. Based on this object, I'm going to call the function called as insert with the parameter scan.next. This is your key and its corresponding value. So we have QPHT.insert key and its corresponding value. Like this, we are going to insert the value into the given hash table with the choice number 1 of insertion. Let us move to the another set of operations. Case number 2. For case number 2, we have enter key. We are going to ask the user to enter the key. And based on this, we are going to call the function. We call the function QPHT object dot method called, that is your function called is remove, and this set is taken from the user. So we have QPHT remove, particular key is taken from the user. Based on this, the remove function is called. So key is removed and its corresponding value is also removed using case number 2. Now we will move to case number 3. We have to enter the key so that the user gets the chance to key and its corresponding value. We have system.out.println enter key and its value is fetched on based on get function. We write down value equal to QPHT, that is the object of the class quadratic probing hash table. We are going to call the function called as get. We write down QPHT.get scan.next, that is your key. This key is transferred here and we get the function called based on this object and its corresponding value is fetched. If you are not able to get the key, its corresponding value won't be available to the user. You must remember, in case of hash table, we have the key value pair. Now we will move to the case number 4. In case number 4, we are going to make sure that the hash table is cleared up. We call the method make empty based on the object of QPHT. We write down QPHT, that is the object of the class quadratic probing hash table dot make empty. This function is called. Once this function is called, all the key and its corresponding values are removed. That is, keys I and val I are made to point to null. That is, they are going to have the value as null. So we can safely say that the hash table has been cleared. Then we move to the case number 5, that is to get the size of the hash table. We have system.out.println. We are going to call the function called as get size based on the object QPHT. So we have size equal to concatenate with QPHT.get size. This will give me some integer value and this is given to the variable called as size. Once this set of operations are done, we also need to write down the condition for default. Let us take a condition where user enters number 7. For number 7, I don't have the list of operations, so it becomes a default condition. For this set of operations, that is the default condition, we write down system.out.println wrong entry. That user needs to be informed that the number of operation he wants to perform is the wrong entry. He has to perform the operation from the given set of value which we have discussed from 1 to 5. Based on this set of operations only, he can go ahead with the functions. Once this is done, then we need to ask the user whether he wants to continue with this set of operations or not. Let us look how we ask the user whether he can continue with this set of operations or not. Once we have given the menu driven approach to the user, now we need to ask the user whether he wants to continue with the set of operations or not. For this set of operations, we have to get the value from the user. We have already defined a variable called as ch of the type char. Before going for this, also we need to define the values of the hash table. That is, we need to display the hash table. We have created the object of quadratic probing hash table class named as QPHT. We need to call this object, and based on this object we need to call the particular function in which we have written the logic to display the hash table. Let us look at the logic. We write down the logic for displaying the hash table. We call the object QPHT. Based on this object, we are going to call the method called as print hash table, which we have discussed previously. In print hash table, we have displayed the values and its key. You must remember, in case of hash table, we have the key and value pair. If you are able to find out the key, then its corresponding value can be found out. But if key is null, then that particular value is not able to reach out. We write down QPHT, that is the object of the quadratic probing hash table, dot print hash table. Once we are done with the printing of the hash table through the object of QPHT, that is the object of the quadratic probing hash table. Now we will ask the user whether he wants to continue with the set of operation once again or not. For this, I am going to write down system.out.println, do you want to continue? In this statement, we have to provide the user which key he needs to enter so that he can continue with this set of operations once again. For this, I have written within the round brackets as type Y so that he can continue with this set of operations. We need to store the choice of the user in a variable called as ch. For this, we are going to write down ch equal to scan.next. This is the object of the scanner class and next method is called. So based on this, we are going to take the value. We write down scan.next method and we are going to call the object of that scanner class. We have scan.nextIt method dot character at location number 0. It is very important to get the character. We have character at location number 0. Let's take an example. We write down character at location number 2. So in that case, if we enters Y, we won't be able to get the value. So the character at location number 0 is to be fetched into the variable called as ch. Once again, we need to remember this value is very important from the continuation of the program. If user enters Y, it means he has to continue with the set of operations. So we need to check the choice of the user. We write down ch equal to scan.next dot character at 0th location. This value is stored in the variable called as ch. This is to define whether the user wants to continue with the set of operation or not. Once this is done, you must remember we have used the do while loop. I have already discussed what do you mean by do condition, and we have defined the set of operation the user can perform. Now we will write down the condition for while. We have while ch equal to capital Y or while ch equal to small y. So if user enters capital Y, then also the value is checked, and if the user enters capital Y, then also the value is checked. So if the user enters Y, whether it's in small letter or in capital letter, we are once again going to give him the menu driven approach for doing the set of operations. You must remember, in case of quadratic probing, we probe the polynomial of the quadratic type and its successive answer is added to the starting value. We have use the equation called as I equal to I plus h multiplied by h plus plus. This is how you do the quadratic probing. In case of quadratic probing, the situation is different. We take a polynomial to calculate the hashing function value. Let us look at the output of the program. First, the user is asked to enter the size of the hash table. You must remember, in case of hash table, we always put the value in key value pair. For simplicity, I am going to use the size of the hash table as 3 only. Once this is done, a set of operations the user can perform is displayed to the user. Let us begin with the first set. As you can see, we have entered 2 entries. These are key is A, value is apple. Key is B, value is bat. Now we will go for the second set of operation. Now the user is asked to enter the key to remove its corresponding value. Let us put up the respective key. Since I have entered the key as B, so its corresponding value bat is also removed from the hash table, and the entry remaining in the hash table is A for apple. Now we will go for the third set of operation. Here the user is asked to enter the key to get its corresponding value. I have entered A and value should be displayed as apple. As you can see, the hash table values are A for apple. Let us go for the fourth set of operation. The fourth set of operation says that the hash table should be cleared. So the value remaining in the hash table is A for apple. that value will be removed from the hash table. Let us look at the output now. As you can see, the output comes as hash table clear. Now we will go for the last set of operation, which is size. Since we have removed all the entries from the hash table, now our size of the hash table should come out to be 0. Let us look at the output. As you can see, the size is 0. You must remember, in case of quadratic probing, we always calculate the value based on some polynomial. Thanks for watching this video. Please subscribe to Ekeeda channel.